Now, the first question, what are the similarities and differences between laboratory thermometer and clinical thermometer? Okay, so when such a question comes, how do you have to answer it? You have to make a column, make two columns. Okay, first you're going to write differences on the top, and then laboratory thermometer, clinical thermometer, then you're going to write the differences. What's the difference, like laboratory thermometer, clinical thermometer? Then another table you have to make, write similarities on the top, and then you can write laboratory thermometer and clinical thermometer, or even like similarities. It's okay if you don't put similarities in a column form, okay? But write similarities between clinical and laboratory thermometer, dash, then put one, and write similarity, two, and the similarity, okay? But difference is always you have to write it in column format, okay? Always you have to write it in table form. So we'll discuss this question right now, okay? Now, first, what are the similarities between laboratory thermometer and clinical thermometer? What are the
Measure
similarities?
how much heat there is.
Say again, Abraham.
They both measure how much heat
There is.
the substance holds.
Yes. They both measure the temperature. They both measure how much heat a substance holds, or they both are used to measure temperature. Yes. Any other similarity between laboratory thermometer and clinical thermometer?
They both can be digital. They both can use mercury.
Yes, they both can be digital. They both can use mercury. Good, Abraham. Any other point?
They both have a metal knob at the
Kink, you mean, right?
in the front.
Yes, correct. Any other point? They both have to come in contact with the substance, okay, or substance or object to measure the temperature, right? Laboratory one also needs to be immersed in the solution, and clinical one needs to come in contact with us to measure the heat. So these are the similarities between laboratory thermometer and clinical thermometer. Now differences. Anna, what are the differences between both?
I'm still thinking the difference between laboratory thermometer and clinical thermometer.
Okay. Emma, what's the difference between clinical thermometer and laboratory thermometer?
Can I see? Can I
Yes,
see?
yes, Ibrahim.
Difference is the laboratory thermometer is long and clinical thermometer is short.
Yes, that is right. And what else?
Laboratory thermometer is more like a tube,
Mm-hmm.
but
Yes,
clinical thermometer is like mm, it's more flat.
flat. Okay. And
Laboratory, this is for non-digital thermometer. Now I'm going to say for digital. Laboratory thermometers, they are part where they measure what you call that, the liquid or something. It's normally longer and it's cylindrical. Like if this is for the clinical thermometer, it will be this big for the normal one because it needs to go in the solution. The clinical thermometer, um, it will not have. It should just finish its square shape and have a bulb.
Hmm.
Then
Yes.
also another difference is the laboratory thermometer's bulb is, I think it's able to withstand acid and most of the substances, but the clinical thermometer is not designed like that because it's only meant to measure clinical stuff.
Mhm. Yes. A major difference, a very major difference is still left out. Then can tell me what is that? Yes, Anna. What is a major difference that is still not being said? Abraham covered a lot of points, but one point is there, one more point is there, a major point. What is that? You are muted, Anna. Emma, can you hear? Abraham, did you figure it out?
Ma'am, no, but please don't tell the answer, ma'am.
Okay. You want to find out and tell. Sure, then I'll wait. I'll wait a minute. I'll give you all 1 minute to think about it.
Is it that the laboratory thermometer is kept in ice cubes, uh, but the clinical thermometer is not?
That is also there, Abraham. Yes, that is there. But this major point is another thing.
Okay, ma'am,
Okay?
wait, just give me a minute.
Yes.
Wait, the clinical thermometer ranges from 35 degrees Celsius to 45 degrees Celsius, which is 94 Fahrenheit to 108 Fahrenheit. But the laboratory thermometer ranges from 0 degrees to 100 degrees.
Very good. Very good, Abraham. This is a major point that I was looking for. Okay, the difference in temperature, like the scale, how much temperature the laboratory thermometer can measure, and on what scale clinical thermometer can measure. This is a very important point. You have to write this in the differences. Okay, this is the one of the major differences between both of them. Okay, the scale at which they can measure the temperature. Also, you can write down that laboratory thermometer is used to measure chemicals, the temperature of chemicals, whereas clinical thermometer is used to measure the temperature of human beings. Okay, that also um, you have to write down. Good, Abraham. Well done. Next question. Give any four examples, each of heat conductor and heat insulator. Can you give me two each, Anna Abraham?
Uh, I will give you two of heat, uh, one of heat conductor, one of heat insulator.
Okay.
Iron is a conductor of heat,
Mm-hmm.
and a heat insulator example is glass.
Plastic, right?
Ma'am, I said glass.
Glass. You said glass. Okay. Good, Abraham. Yes. Emma, this Anna left. Emma, can you hear? Emma, can you hear? Give an example of a heat conductor and a heat insulator.
Yes, ma'am. Can you repeat that?
Give an example of a heat conductor and a heat insulator.
Ma'am, aluminum is a heat conductor.
Okay.
And can you repeat the next one?
Insulator.
Mm.
Example of insulator.
Ma'am,
The left.
Yeah, both left.
Ma'am, I have a question.
Yes, Abraham.
Phone covers made of silicons because when they heat up, the heat doesn't burn our hands. When phones heat up, the silicon doesn't make it burn our hands. Is silicon conducting heat?
Is silicon conducting heat? Like because a lot of materials, like our phone is made up of. Okay.
No, ma'am, not phone. I know a phone, after some time of usage, the phone starts to overheat. I'm asking about the cover. Is that so while the cover is made of silicon?
The cover, yes, the cover is made up of silicon because so that it does not heat up. That is right.
Okay, ma'am.
Our phone does, but our covers usually don't, and our covers protect our hands from getting the heat from the phone. So that is right. Now, Anna, can you give an example of a heat insulator?
ma'am, I can give one.
Yes, Anna.
Rubber.
Rubber. Okay. Okay. All right. Next we have take the correct answer. Transfer of heat by radiation. Anna. Anna, turn on your video. Anna, can you hear?
Yes, ma'am. Transfer by heat by radiation does not require a medium. Heat is
Very
propagated in liquids through conduction.
good.
Fill in the blanks.
Fill in the blanks.
Miss,
Now, yes,
I think it's convection, right? The with the V, the convection.
convection.
That's yes, ma'am. Oh yeah, sorry. Yes, this is conduction. Yes.
Fill in the blanks. I'm going to ask each of you individually. So, temperature of boiling water is
Ma'am, 100 degrees Celsius.
100 degrees Celsius. An iron rod is a dash of heat, Abraham.
Ma'am, an iron rod is a conductor of heat.
Anna, dash-colored objects are good absorber of heat, radiation than light-colored objects. Anna,
Dark colored objects.
yes. Anna, turn on your video. Temperature is measured in degree dash. Emma,
I'm Celsius.
Abraham, the hotness of body is measured by
Thermometer. Clinical thermometer.
yes. Anna, last one. Dash is being used as a fuel to run buses these days.
Is it diesel, ma'am?
Diesel, okay. Petrol also I think can be there.
Ma'am, you can put CNG.
Mostly buses run on diesel nowadays.
Mm-hmm. Yeah, diesel is there. Some will do petrol. Cars are like
Ma'am,
more running on
electric.
CNG.
Electric.
Electricity.
Some buses are electric.
Yes, some buses are electric, some vehicles are electric. That is true.
Ma'am,
But ma'am, for electric, we do not need petrol or diesel. We just have to like charge it.
Charge it, charge the battery.
ma'am,
Abraham.
cars also run on diesel. Like the car that my father has, it runs on diesel.
Most cars run on petrol. Only few cars run on diesel.
And then the bigger cars run on diesel.
Yeah, like my dad's car. Then my mom's car is like run with petrol. My dad's car is the bigger one. So that one is done with diesel.
Some cars run with diesel, mostly the bigger cars. Okay, and right now, like the cars are also doing CNG. Cars are also coming in. Models are there which support CNG. So
Yes,
they are
ma'am.
like both CNG and petrol. Okay,
Ma'am,
yes, Abraham.
ma'am, for CNG, I don't think not many people are choosing CNG because this cylinder takes out so much of space in the back.
Yes, the cylinder takes so much of space in the back.
Ma'am,
So
also it's little rarer to find a place with CNG.
a place with CNG, not really, not so much because you can find it on most petrol pumps. Okay,
Most,
CNG.
ma'am, but if you go like to inside the villages, where
Inside the
like
villages, you might not. Inside the
but
villages
you
and all.
may just find a petrol station over there.
Hmm. Inside the villages and all, not so much, but in the cities, yes,
But
everywhere,
the
it's there.
government is putting an effort to make CNG places more
Mm-hmm.
CNG to be more alive.
Mm-hmm. It's better if you have like more boot space. That is at the back of the car, there is more space. Okay, boot space so that it can like fit your cylinder, CNG cylinder, and you would have some more space to for your luggage and everything. That time, like you can think of a CNG car, but yes, CNG saves a lot of money, quite a good amount of money compared to petrol cars. That is true. CNG costs lesser, like quite lesser compared to petrol. Okay, so now the match the columns. All metals are
Conductors of heat.
conductors of heat. Abraham, when the bulb of a thermometer is heated,
Ma'am, when the bulb of a thermometer is
Heated.
the mercury starts to expand.
Yes. Anna, the degree of hotness or coolness of an object.
Is measured by a thermometer.
Yes. And Emma, dark colored clothes are preferred
In winter.
in winter. Yes. Good. Why is it advisable to wear layers of clothes instead of one thick cloth? Why is it advisable to wear layers of clothes instead of one thick cloth in winters mostly?
Ma'am, one thick cloth will only do like it will not be thick enough, and then if you wear many, the each of that layer will protect, right?
Mm-hmm.
Like a heat conductor.
The many layers will protect you, but what's the reason behind it? How or why?
Ma'am, can I say?
Yes, Abraham,
Ma'am, because it traps air in it.
because it traps air in it. And it doesn't allow the air to pass through the many layers. It traps the air in between them, okay? And you stay warm because air doesn't pass through your clothing. What are the three modes of heat transfer? Anna,
Ma'am, I'm just thinking about it.
Emma, give me one. Emma, give me one name, one mode of heat transfer. Unmute it.
Ma'am, is convection.
Conduction.
Convection, conduction, and Abraham, third one,
Radiation.
radiation. Good. The three modes of transfer of heat are conduction, convection, and radiation. Now, why do you prefer to wear white clothes during summer? Anna,
Maybe because it's a light colored dress and it doesn't attract much heat.
it doesn't trap heat and air passes through the light colors easily or white easily.
Yes, ma'am.
And, next question. Generally, the bottom of a stainless steel kadhai is made of copper. The reason is that, what's the reason why kadhai is the utensil in which we make most of our vegetables at home. We cook our vegetables. So, why is the bottom made of copper?
Ma'am, can I say?
Ma'am, is there an English word for this? Like,
Yes, Amma.
Ma'am, the answer is copper is a better conductor of heat than stainless steel.
Yes. Yes, Abraham. Is there an English word for?
kadai.
Do you know what is a kadhai?
No, ma'am. That's why I'm asking the English word.
It's like a copper pot where you can fry stuff and cook stuff in.
Yeah,
Pot.
basically it's like a cooking pot.
It's like
Yeah.
it's like a pot with two handles. You can buy it if you want it a little deep, and you can buy it if it's a little like on top also.
Hmm. You can like it's like a pot, but doesn't have a small opening. It has a wide opening. Okay? Looks like this, and two handles are there on both the sides. Okay, it has a bigger opening.
Ma'am, is it called a vessel?
Yes, it is a vessel.
Okay, ma'am. Thank you.
Okay. Now, So, because copper is a better conductor of heat than stainless steel. Now, why is the handle of a metallic kettle covered with strips of cane?
Ma'am,
Yes, Abraham.
ma'am, I think the reason is for it to not conduct. So when the person touches the strips of cane, it doesn't conduct heat. And ma'am, the metallic kettle uses electricity, right?
The metallic kettle, they use electricity. The electric kettle uses electricity. Okay. Metallic kettle, there's also a traditional one which do not use electricity, in which you have to put it on the gas stove for the water to heat up. Seen those? Nowadays we have electric. Everybody uses electric, but like before that was the kettle entire thing was put on the gas stove to heat up. So this
Yeah.
is about that, I think. Metallic kettle. Now, why is the handle of it covered with strips of cane?
Ma'am, it's so the strips of cane, like it's a bad conductor of heat.
Mm-hmm. That's right. So that it doesn't get hot and like when we touch it,
That
it doesn't burn our hand. Yes, Anna.
the metallic kettle is a conductor of heat, and if you just touch it, it'll burn your fingers or hands. So they put strips of cane, just like how they use a type of plastic in some of the in
Mm.
like vessels when you heat it up, so you don't burn your hand.
Yes, Anna, that is correct. Um, Even like electric kettle, the handle and the body of it is coated with the type of plastic that it doesn't get very hot from outside. The handle doesn't get hot. Okay, the handle doesn't get hot, so we can easily hold it right after heating up water or something. We can easily hold it. Okay, hold the handle and pour out the water. So that coating is done, okay, and the plastic is used so that it doesn't get hot in electric. While in metallic kettle, this cane strips are used so that the handle doesn't heat up.
Ma'am, in electric, normally I don't think they use metal. Like I have a kettle that uses metal, but like most of the kettles that I've seen in people's houses,
Plastic.
they are they're like they have a plastic handle, and then their body is made of glass, so you can see the water till where you're pouring.
Mm-hmm.
And both do not conduct heat.
Both do not conduct heat. Yes. Yes, there are those. The one we have is has a plastic handle and the outside body has a plastic covering. So it's like not a transparent one, so it's not visible. The inside the water isn't visible, but it has a particular time of boiling. So
Ma'am,
like 1 minute or 1.5 minute.
ma'am,
One
and
minute
some are
basically.
even made of silicone.
Some are even made of silicone. Yes. Now, um, draw a label diagram of a candle flame. You can do this as homework. 11th question. Okay. Drawing a diagram of a candle flame. 12th question. Write the necessary conditions for combustion. What are the three necessary conditions that are there for combustion?
Heat, it's the fire pan. Heat, oxygen, and fuel.
Yes, good, Abraham. We need heat or fire and oxygen and fuel. Okay. These three things, when they come together, they like combustion happens. Okay. Now, why clinical thermometers cannot be used to measure high temperature? Emma?
Ma'am, clinical is the electric one, right? Or the normal one?
Clinical, normal clinical.
Okay, no, the one with mercury.
Mm-hmm.
Maybe there's not enough, like, the scale can only go to a certain amount on the
Yes,
scale
because
can
of
only
that.
go to a certain amount on the thermometer, but on the normal ones, but on an electric one, it can go to the highest amounts also.
Yes, not like electric clinical, but the electric and normal laboratory ones. Clinical, if it's like normal clinical thermometer or even electric clinical thermometer, both are designed to go to only to a certain temperature and not beyond that, because they are for measuring the body temperature of humans.
Yes, ma'am.
Our body temperature. So they do not exceed that scale. We cannot measure very high temperature that chemicals have with clinical thermometer. Yes, Abraham.
Ma'am, laboratory thermometer, ma'am, if uh, what if the chemical is higher than the laboratory thermometer scale from 100 degrees Celsius?
Usually, because the laboratory thermometer scale is very high, mostly all the chemicals they fall under that category only. Okay, under the scale that a laboratory thermometer has. Most chemicals, temperature of most of them are measured because the scale is very high in laboratory thermometers. Okay, but if it is more like, if it is then very high, like even higher than the laboratory thermometer scale, then there must be special techniques to measure the temperature, measure the heat for a particular kind of chemical. But we'll have to look this up, that what chemicals can and the temperature can go beyond the laboratory thermometer scale, and how is that measured? What specific technique is used to measure that? You can check this out. Okay,
Ma'am, the melting point of copper.
the melting pot of copper. Check it out. What is that? Now, why is a clinical thermometer kept under the tongue for taking body temperature?
And is it because under our tongue there's more heat?
There is more heat. Yes, or more nerve endings.
Okay, ma'am.
Why
But
does the
sometimes my mother, when I'm sick, also keeps it under my arm.
under your arm is also good, because the heat is there, body heat is there under the arm, body temperature. Why does the mercury not fall in a clinical thermometer when it is taken out of the mouth?
It's because, ma'am, the mercury has expanded and the glass is not absorbing the heat.
Yes, that is right. Mash the column wood.
Obtained from wood.
Obtained from wood. Kerosene.
Gaseous fuel.
No.
So, liquid fuel.
Liquid fuel.
Coal, solid fuel, and LPG gaseous fuel.
Yes.
Ma'am,
Good.
I have a question. How can they say wood obtained from wood?
Yeah, it's a little weird, right? I was thinking that too. Wood is the fuel that is obtained from wood. Like wood is a fuel obtained from forest or obtained from trees. Must be there, right? Wood is a fuel that's obtained from trees. So, like, don't know how they've written it, but anyways, with this we finish this lesson, heat lesson. In the next class, we'll be starting with the next chapter, that is microorganisms. Okay. that is microorganisms. When shall I give the chapter 6 test of science? Next week, Tuesday? 1 week
Ma'am,
later?
ma'am, I'm not free next week, Tuesday, Wednesday, Thursday.
Why? You're going out?
No, I am going out, but I'll be able to attend the class, ma'am. But I don't think I'll be able to write the test.
Next week, Monday?
Um,
I think next week, Monday also sounds good. So Tuesday we can have like regular classes, and maybe next week, Friday, we can do maths test of like the 5th chapter. Sorry, yes, the 5th chapter, like the second algebra chapter. Today, like this one was just introductory algebra. I have another algebra chapter after that. Maybe next week, Friday, we can do that test. Okay. 2 minutes break for you all. Okay. Go drink water and be back in 2 minutes. Okay, let's begin. Hi, Nathaniel.
Good morning, ma'am.
Good morning. Can I have your videos on, please? Anna, Abraham, and Emma. Anna, Abraham, Emma. Turn on your videos. How many of y'all tried 7.6 exercise? Some questions. Nathaniel's homework I received. Emma and Anna.
My homework is I already sent you, ma'am. I just did the third. I just redid the third question because it is that train.
Ma'am,
Okay,
I
Abraham.
finished it. I need to send it to you.
Send it to me, okay? And Emma?
Ma'am, I finished 7.6. I'll send it to you.
Yes, send it to me so that I'll check and I'll
Ma'am,
share.
also we need to finish 7.5, 7.4, 7.3, and 7.2.
Yes, you need to finish 7.1, 2, 3, 4, 5, all of those exercises, okay? Till 6, and then send me, okay? Okay. Emma and Anna, please share the homework continuously,
Yes, ma'am.
okay? So I'll be able to check it and then I'll take the doubts. Now, 7.6 from that exercise, we'll try a couple more questions, okay? I'll try some more questions. I did the train question with you, poll question yesterday. Today, take a look at this question. A train is moving with the speed of 80 km/h. If its length is length of the train, (120 meters), then how much time will it take to cross a platform 180-meter long? 180-meter long. Okay. If you've traveled in a train, you must have seen that there are platforms. There are platforms on the train station. At the train station, there are platforms. One such platform was here, which was 180-meter long. Okay, 180-meter long. Now, the train that is passing from this platform is 120-meter. Okay, the train that is passing here is 120-meter. Hello, Joshua. Good morning.
Hello, ma'am. Good morning, ma'am.
The train, we have a 180-meter long platform and the length of the train is 120-meter. We have to calculate how much time will it take for this train to cross that platform like this. Okay. To pass that or to cross that platform. Okay, the train is moving at a speed of 80 km/h. Okay, train is moving at a speed of 80 km/h. Now, can you guess how will we do this? How will we solve the question? Can you like tell me if you have a little bit of an idea? You can tell me. What we
Ma'am,
can
do we add 80 plus 120 meters? Number one.
Yes,
Okay.
Abraham. Yes,
And
good.
then we have to convert 80 kilometer per hour into meters per seconds.
80 kilometer per hour into meter per second. Yes, that is right. See, first we have to find out the total distance covered. So we will add 120 meter, that's the length of the train and the length of the platform. Okay, so we have total distance covered gonna be 120 plus
300.
300. 300. Okay. Now, like we have to find out 1 meter distance will be covered in how many seconds? Okay. 1 meter distance will be covered in how many seconds? So what do? We divide it by 360. Okay. For 1 meter distance, 1 meter distance in seconds, we are finding that. Okay. So 3600, that is the second we take, divided by 80, that is the speed, multiplied by 1000. Okay, multiplied by.
Ma'am,
Yes, Abraham.
can we do it the opposite way, ma'am?
Will it be in the opposite way? Try to do it in the opposite way. I think it's gonna be this way because like I'm not using it exactly like this right now. Okay, what I'm going to do is don't cancel anything. 1 meter distance will be covered in how many seconds? 3600 divided by 80, that's the speed, into 1000. That's the conversion for meter. Okay, this is the conversion for meter. This is the seconds, the time, and the speed. Now, this is for 1 meter distance in seconds. 1 meter distance in seconds. Okay, but we have to find out for 300 meter distance. Okay, for 300 meter distance, for 300 meter distance,
Ma'am, will we do 3600 into 80 multiplied by 1000 into 300?
3600 into 300 divided by 80 into 1000. 80 into 1000. Now cancel them. Cancel the zeros first. All the zeros are cancelled. Now cancel the numbers. We can cancel with 2. 36, how many times in 2? 18. 2s are 2 2s are 2 9s are 9 into 3 divided by 2. I have 9 into 3 divided by 2, which is 27 by 2. 27 by 2 seconds. You can also divide it. If you divide 27 by 2, you will get 13.5 or 13 and a half. Okay, or 13 and a half seconds. Okay, 13 and a half seconds. See, we need to find out the total distance, that is my length of the train and the platform. My train and platform is gonna be a total distance. Add them First step is we add them both. Next step is we have to find out 1 meter distance. What will be 1 meter distance in seconds? We convert it always into seconds. Why? Because we are finding, whenever we are finding the time, it's going to be in meter per second. It's going to be in meter per second. In the questions here, we are going to calculate it in meter per second. So both the conversions we need to do. We need to do the meter conversion also, okay? And we need to do the time conversion also, okay? We have to make it in seconds, meter per second, okay? So for meter per second conversion, we use 3600 per second, and for meter 1000, okay? Now, 80 was my speed, okay? 3600 seconds, okay? That's for the second conversion. We are going to divide that by speed multiplied by 1000 to make it in meter per second. But this is for what? This is for 1 meter. This is for 1 meter. We are doing 3600 divided by 80 into 1000. Then this is for 1 meter. The equation that like the structure that we made for 1 meter. We have to find out for 300 meters. So what we do? We do 3600 multiplied by 300. Okay, multiplied by 300 divided by 80 into 1000. I think you can also first solve this. First solve this thing. Another alternate method is first you solve this part and multiply it by 300 to find out the distance, to find out the time taken for to cover 300 meter distance. You can solve the upper equation and multiply it with 300. That also you can do. Second one, we have taken it together and multiplied it. We got the time, that is 27 by 2 seconds. If you are writing it in fraction also, if you do it in only fraction, if you write just 27 by 2 seconds, it's the correct answer. Okay, or you can divide and write 13.5 seconds. Understood? Understood all of it?
No.
Yes, Abraham.
How did we get the time by finding out 1 meter?
How did you get the time by finding out 1 meter?
Ma'am, is this distance equal to time into speed? So then why did we multiply by 300?
Why do we multiply by 300 is because we need to find for 300. Okay, that is the total distance covered. Okay, we have to find for 300 and we have to do the conversion. Okay, we are finding for 300 meter in meter per second. Okay, in meter per second. It's not just simply you have to find the time, okay, when all the qualities are equivalent or the qualities are equal, quantities are equal. You have to do a conversion here. Okay, you have to find the answer in meter per second. So for per second, we take 3600. For meter, we take 1000 and then we solve it.
Okay, ma'am. So, ma'am, basically you were doing the conversion, ma'am.
Mm-hmm.
But then, so because it was in 300 you have to convert it to meter per second. You
Yes.
put 300. You put 3600 in 300 and then divide it. Understood?
Yes, divided and then divided by speed into 1000. Okay.
Ma'am. Thank you.
Joshua, understanding?
A bit, ma'am.
A bit. Okay.
Ma'am, I had a question about the homework yesterday.
Yes, Nathaniel.
I was finding question number 7 a bit hard.
Question number 7 a bit hard. Okay. So tomorrow I'm going to take your doubt class of 7.6. Okay. Tomorrow I'm going to take your doubt class of 7.6. All of you, please complete 7.6 by today. Today is the last day. Tomorrow I'm going to ask your doubts. All the doubts that are there in 7.6, we are going to do them in class. Okay?
Ma'am.
Yes, Abraham?
You're not done one question with us.
Not done what?
You'll not explain one question that is there in 746, ma'am. But you still have to explain. Then the
Okay.
last question, Nathaniel said, the seventh question. Two races, P and Q, take part in a competition. Races Q starts running when races P has cover. I don't think, ma'am, you have done this question with us.
Two racers, P and Q. Okay. I'll take this question with you. Okay. I will take this question with you, a similar question with you, and also finding the length of the train question with you. Okay. Finding the length of the train with question with you. I did time, finding the time. Okay. Finding the length question and the racer question I'll take. Shall I clear the screen right now?
Yes, ma'am. Ma'am, I
Yes,
have a
ma'am.
small doubt.
Yes, Anna.
Don't you think the exam on Monday and on Friday for maths and science is a bit too early? Keep it the next week after that.
No, Anna, that would be too late. I think science 1 week and maths 9 to 10 days is enough.
Ma'am, you can use you can move maths first and you can move science last.
Okay.
No, I don't want maths first.
Ma'am, please, maths will be easier than science.
Yes,
No,
ma'am, use
ma'am,
maths
science is
first.
much easier than science.
Ma'am, maths
I
first.
want science
Um,
first.
okay,
Maths
listen.
first.
Listen. Today is Tuesday, right? I said next week one test on Tuesday, one test on Friday. So if we like do science first also, or like maths first, you're gonna get a one whole week, like this Tuesday to next Tuesday to prepare, right? Like a 1 week is enough for the preparation. 7 days. Any test?
Ma'am,
Yes.
ma'am, like if we do for maths, ma'am, the thing is that maths will be easy. Science will need a little more time because of the diagrams and everything.
Yes, ma'am.
Maths, if you know the concept, it's easy to give the test.
We have algebra in maths, fifth chapter. Okay, and let me check how, like, is it a very long chapter or is it a short chapter? I think it's a short chapter, the fifth chapter.
Ma'am, you can keep science on Tuesday and maths on Friday.
Ma'am, sixth chapter, not fifth. Fifth is the test we did on
That's
Friday.
fine with me as long as science
Sixth
is first.
chapter. Sixth chapter in maths, right? Or fifth
ma'am.
chapter?
Six.
Abraham, I give you fifth chapter test.
Yes, ma'am,
Sorry,
you gave us
fourth
the chapter
chapter.
5 test this in science.
In science, I gave chapter 5 test. Maths, I gave chapter 4 test.
Yes,
So,
ma'am.
fifth chapter test will be there in math, and sixth chapter test will be there in science. Fifth chapter in maths, we have 5.1, then 5.2, and 5.3, 5.4, and 5, and 6. But like they are very small exercises. They have 6
Ma'am,
exercises in maths, but
Ma'am,
very small.
we'll do maths first.
ma'am,
2 to
maths
3
first.
questions are there.
Ma'am, so
Maths
do maths first, then do science.
Okay, so Tuesday is gonna be maths. Okay, maths test to chapter 5, and Friday next week gonna be science test of chapter 6.
Okay, ma'am.
Okay, now Joshua, did you do the test? Did you try it out?
No, ma'am.
No. You were going to do open book, right?
Yes, ma'am.
So please do it. Okay, do open book. Okay, but do it. Okay, because it will give you an idea of how to solve, what kind of questions were there in the test. Okay, so you'll be able to get an idea about that. So I want you to attempt it, even if you do open book. Okay, I want you to do it and ask me your doubts.
Okay, ma'am.
Okay, and Anna and Abraham, I need the papers today itself.
Yes, ma'am, I
I'll
finished
check
science
them.
and maths.
Ma'am,
I
the
will
science,
send
ma'am,
it
the
to you.
science test like 1, 2 questions are remaining. The maths test is I'm completing.
Okay. So I'll send it to me by today. So I'll check them by today or tomorrow, and I'll share the results with you.
Ma'am, I
Ma'am,
sent one.
I
You sent.
asked, ma'am, I just wrote the answers. I did not write the questions for the test, both on.
That's okay. Not a
I-
problem. Not a problem. If you wrote only answers, that's okay. All right, no problem. Now, let's check out the finding the length of the train question. Okay, finding the length of the train question. Now a train is moving with a speed of 60 km/h. Okay.
Ma'am, can I go to the washroom?
Yes, Abraham.
Thank you, ma'am.
Speed of the train is 60 km/h. Okay. Length of bridge. It crosses a bridge whose length is 220 meter and time taken for it to cross the bridge is 24 seconds. We have to find the length of train. Okay, see, a train is moving with a speed of 60 km/h, crosses a 220 meter long bridge in 24 seconds. In 24 seconds. Now we have to find out what is the length of the train. Okay, so what will be the length of the train? Like total length of the train, we in the previous question we added the length of the train and the platform. All right. In this question too, if we add it, okay, if we add it, it is gonna be like the distance covered will be distance covered will be length of train plus length of bridge. This is what we did in the previous question, right? Length of the train plus length of the bridge will be your total distance covered. Okay. Now length of train is X. I don't know. Length of bridge is 220. Okay. But I don't know the total distance covered. So first, if I calculate the distance that is covered, then from that I will subtract the length of the bridge to get the length of the train. Okay. When I will have this amount and I will have, this number that is the total distance. From that, when I subtract bridge, I will get train. Okay. When I subtract bridge length, I will get the train length. So first, let's find out this quantity. Okay. For this, we have time taken is 24 seconds. The time that it took me was 24 seconds. Okay. So now we know that we take 3,600. Okay. We take 3,600 and like seconds. So 60 km was my speed multiplied by 1,000 meter, or like you can write this down like this. In 3,600 seconds, 3,600 seconds, distance covered distance covered will be 16 to 1000, right? 16 to 1000. Okay, so now in 24 seconds, distance covered will be same thing that we did in the previous question. That time we multiplied, okay? Here also we multiply with 24, okay? So 60 into 1000 divided by 3600 seconds into 24. Solve this and find out in 24 seconds how much distance will be covered. Solve this and find out in 24 seconds how much distance will be covered. Emma, Nathaniel, Abraham, videos on.
Ma'am, just a minute, I'll be back.
Okay. Abraham, saying something?
Yes, ma'am.
You said something? Did you say something?
No, ma'am.
No. Okay. Emma, video on, please. Emma. Emma, turn on video. Yeah. Solve this and tell me in 24 seconds what will be the distance covered. Rishwa, solve it.
Pardon, ma'am?
Solve it. Solve it and find out.
Okay, ma'am.
Anybody got the answer?
No, ma'am,
Ma'am,
I'm
is the
doing it.
answer,
Ma'am, I'm
ma'am,
still
is the
doing
answer
it.
400?
400. 400. Correct.
Yes.
Now, 3600 and
Ma'am,
0 to 0 cancels. Then we have 36 and 60. Okay, that can be cancelled. 6 ones are in 0 and 6
ma'am,
how
you
many
have to,
times? Yes, and yes, Emma.
ma'am, 6 are 36. So
6.
6.
6, yes. 6 ones are 6 fours are 10 into 10 into 4. We have 400.
Good, ma'am.
10 into 10 is 100. 100 into 4, 400. Okay. In 24 seconds, distance covered is 400. So
Ma'am, is the
here,
length of the train 180 meters?
180 meters.
Yes, ma'am.
Yes, Abraham.
Ma'am, you have to minus the length of the bridge from the length of the.
From the total distance.
So basically the opposite of what you thought in the other side.
Yes. Yes, this is just the opposite of what we did in the previous question. So to find out x, I'm gonna do 400 minus 220. X is how much? 180. So I have,
Ma'am,
yes,
I have a question, ma'am. When we are calculating the time, ma'am, we put the 3600 below. Above, when we're calculating the distance, we have put 3600 below, right?
yes, yes.
Okay, ma'am. Thank you.
Okay. Whenever we are calculating distance, we put 3600, that's it. That's your seconds below. And when you're calculating time, you put it above. Okay, but make sure you multiply it with the quantity that is given. Like 24 we multiplied here. In the previous question also we're multiplying like this, right? So to find out for that, you have to multiply the set thing with the quantity that is given to you to find it out. Okay, understood the question? Understood this question?
Yes, ma'am. A bit, ma'am.
Okay. Joshua joined in one of the hardest chapters.
Maybe, ma'am.
Yeah, but it's okay, Joshua. You'll be able to like do it when as we proceed. Okay.
Okay, ma'am.
But send me your homework, Joshua. Okay, try out the homework. You can look at the classwork questions, then try out the homework questions. Okay, then you can mark your doubts and you can ask your doubts in class.
Ma'am,
Okay. Yes, Abraham.
you're wrong. This is not the hardest chapter.
It's still not the hardest chapter. One of the
Ma'am, the
hardest.
ninth one is the most hardest, ma'am.
Yes, ninth chapter is the hardest. Yes. But I think for you, Abraham, the like concepts would have been like learned by you by now. Is that so?
I'm not sure.
Not sure. Okay. You know, Joshua, even Abraham joined in the seventh chapter, ratio and proportion, in the middle. When I was teaching last day, when I was teaching proportion, that time Abraham joined in proportion part when I was teaching the seventh chapter. Then we finished seven, then I did eighth, then ninth. So ninth chapter is like your simple interest, compound interest, one of the hardest chapters that like most of y'all find hard, might find very hard. But we'll do it. We'll break it down, and do it in an easy way. Okay.
Okay, ma'am.
Ma'am, even algebra was easier.
Yeah, we'll do it. Don't worry about it. We'll get it done. The ninth chapter. Okay. Now, tomorrow I will take the racer question. Okay, first, and then I'm going to take your difficulties of like 7.6 exercise. Okay, because like it's already 9 around right now, so I'm not starting with the racer question right now, but tomorrow. First, I'll explain the racer question to you. Then I'll take your doubts from 7.6. Day after tomorrow, I'm going to take your doubt class of the test. Okay, we'll be discussing the test for this thing. Your chapter 4 in maths algebra, we are going to have a discussion on the test. Okay, so before that, today I need your copies. Okay, test papers. So till tomorrow I'll check it. Okay, day after tomorrow we'll discuss it in class. The test paper.
Ma'am,
Yes, Abraham.
ma'am, I have a question about the test papers.
Okay.
You're saying a bit that like you're gonna we're gonna discuss the test papers tomorrow, day after tomorrow.
Day after tomorrow.
And tomorrow we're gonna do the doubts. But ma'am, our 7.6, ma'am, mine and Nathaniel's are mostly done. We already submitted the things to you. This is the seventh question that you have not not helped us in is not done.
Not done in class. Seventh question, the
Yeah.
racer question isn't done in class. So tomorrow I'll do the racer question. So probably Nathaniel and Abraham, your doubt will be clear in tomorrow's class 7 chapter. For Anna, Emma, and Joshua, if there are any doubts from the 7th chapter, you can ask me tomorrow.
Yes, ma'am.
Okay?
Yes,
You can
ma'am.
ask that to me tomorrow. And
And
tomorrow
ma'am,
we'll go back to the 7th chapter. Yes, Abraham.
ma'am, and how do we solve the speed
How do
for calculating the speed of a train?
calculating the speed of a train? I'll take this tomorrow. Okay? I'll take this as a doubt tomorrow. Okay? If it is just basic speed of the train, then you can use the speed formula. Okay? Use the speed formula. Remember, I taught you all the three formulas at the start for distance, also speed, also, and time, also.
No, ma'am,
So,
it's not the normal speed. It's like 200 meter. It's 360 meters. This is the length of the train, 40-meter bridges, and in 20 seconds. So, ma'am, basically we add it and then we divide.
we add it and we divide. But I can
20.
do and show you tomorrow. Okay?
Okay, ma'am. Thank you.
In the doubt class. Because it's time already. We'll do and see it. Okay? We'll do racer. I'll take doubts. And day after tomorrow, we'll do test discussion. Math test Tuesday of this thing, chapter 5, and science test of chapter 6 on Friday.
Yes, ma'am.
Okay, then. Till tomorrow. Have a good day.
Bye,
Bye.
ma'am.
Bye, ma'am. Thank you, ma'am.
Bye,
Bye,
ma'am. Thank
Nathaniel.
you.
Bye, ma'am. Bye, Jason.